here we go. 7.1, applications of triangles. We're going to solve a right triangle. I'll explain what that means in a moment. Do some applications with it, and then the bearing of an object, that'll be part 2. Okay, we'll talk about what that means when it comes to trigonometry. So let's just start solving the right triangle. First example. This feels weird, no definition, no theorem. We're just jumping into it. Solve the right triangle. Round lengths of the sides to 1 decimal place. Okay. Wow, that is not a right triangle. Let's try that again. I don't know what I was thinking there. There you go. Couple things. First, I want us to note something here. From now until, well, whenever we're done with this semester, you're going to see them naming triangles using capital and lowercase letters. Okay, can they still use Greek letters, alpha, beta? Yeah, they can still do that. But when we do law of sines, law of cosine, stuff like that, they're going to start using capital letters for angles, lowercase letters for sides. Okay, so I'm going to put that here. Capital letters, from here on out, we're going to name the angle. And then lowercase letters for the sides. Now, they do pair them up nicely. So for instance, look how angle A is across from little a. Okay, so that's how they pair things up. So here's C, big C, it's across from little c. And then big B is across from little b. Okay, so that's how they pair all these guys up. So that's going to be more and more routine for us as we're going through it. Well, let's solve it. What can we solve rather quickly? Which piece of information can we find?
No. A.
A. How many degrees in a triangle?
180.
180, right? So if this is 40.8, that's 90. I can what? Subtract this from 180? I get angle B, or angle A. That's the easiest one we can start with. So let's do that. So the measurement of A is just going to be 180 minus our 2 angles. And we get 49.2 degrees. So that was simple. Remember those days back in geometry? When you're just finding angle measurements? Now, the 2 sides that we need are little c and little b, right? And we're going to use some trig to figure that out. Let's start with little b. Okay? And here's the deal. You can use a lot of different methods for this. Just depends on what you feel like using. Because they give me this 40.8, I'm going to use it. Now, could I use this for finding side lengths? Yes. What I would suggest when you're finding measurements, use what the problem has given you. Because if you made a subtraction error and you use it for the other calculations, everything's wrong, right? So just keep that in mind. I'm just going to use the 40.8 because it's there. So using this, if I want to find, let's say b, for instance, I could do tangent. So for instance, I could do tangent, which is opposite and adjacent. So tangent would be a good one to find b. Okay, so let's give it a shot then. Let's put down here. So tangent of b is going to equal little b over a. I'm going to plug the values in. So tangent of 40.8 equals little b over 12.1. If you would like, sometimes it's nice just to see a fraction equal to a fraction. And then to solve it, I'd multiply both sides by 12.1 just to finish it, right? To get b by itself. So that's what we're going to do. So b is equal to 12.1 times times tangent of 40.8 degrees. I would advise you not to do this, and you guys have been good with it, but if you did this, if you type that in the calculator with no parentheses, they're gonna think you're multiplying the angle by it, then take tangent, and that's no bueno, okay? So in the future, and I don't think it's gonna be an issue with you guys, but always put the integer or value, whatever it is, in front of the trig ratio. Okay, calculator time. So we get, comes out to be 10.4. We got one more side to go. We gotta find what? Side C. And you got options. Because it's a right triangle, there is something we could use from geometry. What is it?
Pythagorean theorem.
That's it, good old Pythagoras. Now, what I would recommend in this case is maybe not use it. Only reason why is the same reason as before. If you did that incorrectly and used Pythagorean theorem, that's gonna be incorrect, right? So I'm gonna use the information that the problem originally had to solve for the next one. So what I'm gonna do is, well, let's see, we got A, huh? So cosine would be next. So adjacent with hypotenuse, very good. So let's do that. So cosine of B is equal to little a over little c. So we get cosine of 40.8 degrees equals 12.1 over little c. And again, if you want to put it over 1, just to make it easier to see fraction equal to a fraction. So to solve for c, I'm going to multiply both sides by c to get the 12.1 by itself here. So c times cosine of 40.8 equals 12.1. And then we'll divide to finish. So 12.1 divided by cosine of 40.8. And we get this to be 16. So when they ask you to solve a right triangle, you're finding all the measurements. That's all sides, all angles. Okay? And you have choices here. And again, I don't want to. Are there going to be times we're going to have to use the values we calculate to find other ones? Yeah, we're going to be forced to. It just happens. But in this case, I didn't have to do that. I can actually use everything I had originally to find all the values there. All right, let's do an application problem. So here's what happened. My cat, Louie, is stuck in a tree. The distance, and I actually do have a cat named Louie, the distance from me to the cat is 90 feet. The angle of elevation to Louie is 47 degrees. I myself am 6 foot. So my question is, how far up is Louie? And I did eye. I'm pretty good at eyeing things. So I'd say roughly about 90 feet for me and the cat, which is pretty cool. I used to carry all kinds of math stuff with me at all times, because you never know when you might need it. I used to carry a projector in the back of my vehicle, because you never know when you have to teach math. It can happen. No, I was just transporting it. But I told people, I was like, oh, I always have one in the back of the vehicle just to teach. I would draw a picture. Now, you don't have to, but I think a picture is a nice way to kind of put your information together. So let's draw me. I don't have that much hair, but that's okay. One can dream. There we go. And I'm 6 foot. little bit of a demon cat. So let's see. Distance from me to the cat, 90 feet. Okay, angle of elevation. Let's recall what that means. So if I were staring at the door currently, that's my eye level. If I were to move my eyes to the top of that flagpole, that change in my eye movement is my angle of elevation. So here's me staring at the tree, and then if I look up to where Louis is, that angle elevation will be 47 degrees there. Okay? So now, I want to know, how far up is he? That's the unknown part. Okay? And it is a little silly. I mean, again, do you have to draw the picture? No, but I think it kind of helps. Especially if you're really good at drawing. Obviously, I'm good at drawing, so you know, I want to make sure I draw pictures. So here's my little right triangle here, and I want to figure out this guy. So here's what I'm thinking. If I figure out my eye level to where he is, the height of that guy, then can I add the height of me and get the total height? Does that make sense? So that's what I'm going to do. Okay? So I got to find this value. I'm going to call it little h, and then I'll find big H afterwards. So let's find little h. So what trig ratio can I use to find little h? Sine, yeah. Because it's what? Opposite with hypotenuse. Because let's go ahead and use it then. So sine of 47 degrees is equal to h over 90. Again, we'll just put over 1. So I've multiplied both sides by 90 to get h by itself. So we get 90 times sine of 47 degrees. And when we do that, we get roughly 65.8, what is this, feet? Yeah, feet. But again, that's not the height I want, okay? The height I want is the full length of this guy, okay? So this is a tall tree. So my total height, which we'll call big H, because it's gonna be the 65.8. My cat's a good climber. Plus 6 feet, so we get 71.8 feet. My final answer there. All right. Wait, questions? All right, let's try one more, and we're gonna go to Canada for this one. Did you know that the tallest freestanding tower in the world is in East Liverpool? No, I'm kidding. Is the CNN Tower in Toronto, Canada.
What's we like freestanding?
There's nothing supporting it. Nothing. It's just standing on its own. Here's the best part. There's a restaurant on top of it.
Oh, so unsafe.
I thought so too. The tower includes a rotating restaurant high above the ground. So you better make sure.
Rotating. Oh my gosh.
Yeah. So hopefully the engineers
Know what they're.
did their job. It's like a Final Destination moment, isn't it?
And if the people will pledge it, you worked on it.
Any senior that is planning on attending any of the Kent State University regional campuses or the main campus, the Kent representative is here in room 104. Please come down and talk to her. Thank you.
From a distance of 500 feet, the angle of elevation to the pinnacle of the tower is 74.6 degrees. The angle of elevation to the restaurant from the same vantage point pinnacle of the tower is the restaurant located. So I got two angles of elevation here. But that's okay. We'll mess with those. But first up, we gotta draw pictures. And we know how good I am at drawing pictures, so let's just keep this going. Okay. So here we go. So here's my tower. No, it does not look like this. There it is. Here's my vantage point. Okay. And from the very top of the tower, okay, from here to here, we have a measurement of 74.6 degrees. It's the very top, the very pinnacle of it. Feels weird with no person there, huh? Guess what? I'm back. There we go. That's me watching. Man, it just looks like I'm very grumpy right there, but that's okay. There you go. I'm very amazed by it. Now we have another angle of elevation to restaurant, which from here to here is 66.5 degrees. Okay? So again, with two angles of elevation, you gotta be careful on how you draw it. And the last thing we know is that it's what, 500 feet from this right here, which is our vantage point. So that's right here. I should have done that. Oh. So now we gotta figure out the height of the tower itself, and then what's the difference of height with the pinnacle of the tower to where the restaurant's located. So there's two heights I'm trying to figure out here. So let's give it a shot. First, let's figure out the total height of the tower. I'll call that big H. Okay? Now, if I want to find the total height, which angle of elevation am I going to use? Yeah, 74.6. So looking at this is like my right triangle here. Let me just complete it. So what trig ratio would I use to find that height? The tangent. Yeah, very good. So tangent, 74.6 is h over 500. So the 66.5, we'll use that to find the difference between the pinnacle and the restaurant. Multiply both sides by 500 to get h by itself. And we get 1,815.2 feet. Now, we want to find the difference in these heights. So here's what I'm thinking. Because we know the entire height here, I could find the entire height from the ground to the restaurant and subtract them. That'll give me this height that I want, the differences of it. So let me, I can't use H anymore. Let's use capital A, okay? So we're gonna use A, find what A is, and then subtract the two. That'll give me this little section here. So we're gonna use tangent again. Tangent of 66.5 degrees is h over 500. Same procedure, we'll multiply both sides by 500 again. I used H, oh my gosh, capital A. There we go. So A is equal to 500 times tangent of 66.5 degrees. We get 1,149.9 feet for that guy. Kind of rushing here because we have like a minute or two left, which is fine. This is our last example anyway. So now to find this guy right here, I can subtract these two heights and I'll get my final answer. So let's go ahead and do that. So the last step, so the difference in heights $1,815.2, less than $1,000, $149.9. And we get 665.3 fee for that guy. And there we go. Any questions? Awesome.